Hi, my name is Jay Kors, and I'm one of the vision application engineers here at KMV Systems. And today we wanted to give you a behind the scenes look at our smart AI technology that we are implementing on our systems. The smart AI technology that we're using has been able to help us solve a lot of applications that were unsolvable or very difficult to solve in the past by traditional vision tools. And in addition to helping us solve unsolved applications, it's making current applications even easier than before. So what we're going to do today is show an example of some defects that we're looking for, and that's part of what AI is allowing us to do is find defects that fall into the anything anywhere category. So we're going to look at a couple types of defects today, and we're going to look at these 1 gallon plastic containers, and hopefully we should be able to find all of the defects that we're looking for. So for example, on the left side here, we're going to be looking for this defect. And the thing about this defect is that we've got a couple samples where it looks larger like this, easily seen by the human eye. But I believe we've got some that we're going to have, smaller regions that may not be as quickly identifiable. And then on the right side here, we're going to have some die lines like this. And with traditional tools, this wouldn't typically be that bad, except that this is going to fall anywhere on top of the containers we're looking at here today. So as we go through these, one thing to note is that the smart AI really acts like your best operator on their best day every day, in that we can train it on good images and good samples, and it should perform the same way against every sample that comes through. So if we take a look at the software here, and I've already gone through and trained the neural network, but the process for this is that we take a large sample of images of good samples and we run them through the neural network, and that's what we train off of as good. And then we challenge it with good and bad samples to see how it performs. So I'm going to go through a couple of these images just to give an idea of the range of defects we can identify here. We'll go from very large gross defects like the die lines we looked at already, and then we'll get down to some smaller stuff that would have most likely not been caught by traditional vision. So here is a good sample of the die line defect that we're looking for. And this is, again, pretty gross. Traditional tools may have been able to get this, but the problem is as this moves, may get through the traditional tools. And we can see I can toggle the heat map here, which gives us a little bit better feedback onto what exactly is being found in the area, if you will. Now, as I find a couple other defect samples here, this is the defect that we already showed as well. We're looking at the handle and we're seeing the material. But I want to find a couple other images that are very impressive, if you ask me. Here's a good sample or a good example of a die line, but not even on the top surface. And we're still actually seeing this with the smart AI. It's finding it, it's identifying it as a defect, something that's not typically there or should not be there, as it did not see it in the good samples we trained on, and it provides us the feedback of it. Here's another one on the other side of the handle, and we're catching that one as well. So really, we can look within this entire region and find anything that varies from our good sample set. Here's an even smaller one, and this one's incredible. If we go down here and take a look, and I turn off the heat map, this is actually a die line, and we may have another camera on this system that would be seeing this from the side view, but even if it wasn't, we're actually catching it from the top using the smart AI. Now, during the training process, we do have some statistical data that is used when we're trying to identify how well our tools are performing. Typically, we want to see a nice divide between our good samples and our bad samples, and there's a statistical scoring that is occurring here that provides a deviation from that. And then, of course, we have thresholds that we can adjust on our own, and that determines the pass and fail threshold that is followed by the tool. So in this case, we trained on 44 images, and we've got very, very good results with that. 44 good images. We have 180 images total. And so our results here are, 25% of the data has been trained on, and the other 75% is being provided back by the tool based off of the training set. Here's another one. This is one that I was looking for. Very, very small, difficult to see from the field of view that we've got. But as we zoom in, we can, of course, see that there's some sort of defect occurring here. And the smart AI was able to catch that without any problems. Okay, I think that does it for what I wanted to share of our smart AI technology. If you have any questions, please feel free to visit us at kmvvision.com or send us an email at info.kmv@kmvvision.com. Thank you.